Hello everyone, welcome to our presentation. We're going to be talking about the analysis of the Chicago crime data set. This is for CIS 8693 data analytics for DI. In the presentation, we're covering about the data set, the problem statement we're solving for, a visualization of the charts and graphs, data pre-processing, which is cleansing of the data, data modeling, evaluation of results, and insights and suggested actions. The project is based on the City of Chicago crime data set, which is available on Kaggle for everyone. The time frame is from 2012 to 2017, which is a nearly 1 million records in the data set. It's a huge data set. The key features include incident details of the crime, offense types, locations, the arrest data, and community areas in which the crime occurs. The problems we're solving for are assessing the arrest likelihood, determining how likely an arrest is based on the type of crimes and where it happens, the crime type prediction, which is the types of crime which are likely to occur based on certain location factors, analyzing the patterns within this data, and looking at trends in different types of crimes across the city over different periods of time, and the strategic law enforcement response, which provides useful information that helps the police to improve their response to crime. So we have various variables. The dependent variable is marked in green over here, which is arrest, and the other variables are all independent. The ones in black are removed, and we'll be talking about exploratory data in the next slide with Parini.
So we have used Tableau tool to do the exploratory data analysis. We'll quickly go through the Tableau dashboard for that. So here what you are able to see, this is the map of Chicago, which shows the crime locations with color intensity representing the frequency. The darker the area, the higher the crime density. And also over time, we are from 2012 to 2016, we are able to see that there is change in the pattern. Moving on to then, so here we see the 2016, for year 2016, there is a breakdown of crime type by reported cases and the arrest done. The small and Here we can see that the theft leads the crime type and the narcotics lead the arrest. And there is disparity between these two graphs, and that we can conclude from this exploratory data analysis.
Yeah, so in the data pre-processing slide, we are going to see the process of cleaning and preparing the raw data before we are using it for the Azure ML model. So we have deleted columns. These columns were removed because they do not contribute to the prediction. We have data cleaning part. We have cleaned the missing values. So for this task, like we have removed these from the values were not available, so we have removed done the cleaning for this. We have split up our data into 70% training and 30% testing set. Then we have the models, types of models, that is decision tree, random forest, along with clustering, k-mean clustering. Then we have dependent variable as well. That is, clustering doesn't has the dependent variable because it is unsupervised model, and other than two, we have arrest as the dependent variable. Also, we have the independent variable, which predicts the outcome of a dependent variable, that is like data, primary type, stochastic, beat, etc. The model types of model approach and reason which we have used is k-mean clustering, two-class decision forest, and random forest. K-mean clustering because it helps in identifying the patterns or hotspot, like grouping it and identifying the hotspot and pattern. Two-class decision forest because to predict the likelihood of the arrest by analyzing the past or past crimes. And random forest for the same purpose, and we have done the comparison between the later two models.
Yes, so I'll talk about the very first model, which is k-means clustering. We experimented with k as 3, 5, and 6, but finally considering the data and then the context of our data set, we were able to conclude that k is the most optimal option for us. In the left-hand side, you see the results that were generated through Azure ML, and on the right-hand side, you see the visual representation of the clusters. I'll talk to you a little bit about why we believe K5 is the best option. Moving on to the next slide. Finally, with k equals to 5, the model was able to produce tighter, more compact groups. And at the same time, we were able to identify that the clusters had better distribution, offering enough separation to differentiate the data clearly. Another reason why we didn't want to go for 6 was also because we would be increasing another cluster, but from a data standpoint, we didn't see much value in the output for us to go ahead with it. So according to that, we all contributed to deciding that K5 was the best option for K-means clustering in considering our data set. So the next model, Janvi will talk about it.
Yeah, so the second model we did was two-class decision forest. We excluded a few columns before splitting the data into 70 training and 30 validation. We trained the model on arrests, and we basically did this to predict the likelihood of an arrest in certain areas. So as you can see, the accuracy of the model is 82.5%, which means that the model correctly predicted 82% of the times whether an arrest will be made or not. The ROC curve, as you can see in the figure here, hugs the top left corner, which indicates the model effectively distinguishes between cases where an arrest was made and where it wasn't made. There is a high AUC, the area under the curve, which suggests the model has good discriminative power and can accurately predict arrests. A steep initial rise can be seen in the lift curve over here, which indicates the model is able to identify true positives early on, which is crucial for practical application like crime prediction. And then there is a high precision of 97%, which signifies that it predicts positive cases almost correctly. The only thing to be noted here will be covered in, which is the recall rate, which is probably something that the next slide of random forest will cover. And Yaridzi will take you through it.
So for random forest, we're basically looking at the R squared, which is 54.6%. This indicates that the model explains over half of the variation of the probability of the arrest. So this is based on the type of location, time, and factors. And the root mean squared error is 29.5%. And this is basically the model's prediction outcome of about the level of the error of the model, fairly reliable, but it's not perfect. And some of the key factors is FBI code, just as the other model that John presented, that is a top predictor of an arrest following the other crime types and etc. Comparing the random forest and two-class decision tree. So for random forest, we're looking at it helps us understand the various crime types and the likelihood of an arrest. So for instance, if we look at different types of thefts, we can compare from small to large. And then the two-class decision forest is more predicting of what will happen of an arrest or not. And just to recap everything, it's understanding whether if it's the factors that play into effect for random forest, and then the two-class decision tree is more of will it happen or not.
Okay, finally, I'll talk to you about the recommendations. The very first recommendation that we would like to provide is allocating resources. Basically, law enforcement can conduct targeted resource deployment, ensuring patrols are positioned effectively. And then we could also recommend putting together customized prevention strategies. And another recommendation would be, the third one that we would like to provide is providing training and development for officers. Basically, if certain areas are prone to crimes but low arrest rates can be observed, we could provide training, specialized training in conflict resolution and de-escalation techniques. Policy interventions would be another recommendation that we would like to provide. And also the last recommendation that we would like to provide is community engagement, because we believe the change has to come through the community. So we would like to, through our models, we will be able to foster direct collaboration with community members and prevent crime. So in conclusion, this is our take on crime prevention in Chicago using the data that's available. And that is it from my end. Thank you.